Okay, now let's talk about how the BJT works. So previously we talked about how the BJT works in terms structurally. So now we want to talk about to learn how the BJT works, to explain it in a energy band diagram. I don't know why my pen is like, terputus-putus. So now, so we learned before how to draw the PN junction using the energy band of PN junction. So as we the and this BJT is just the this BJT is just a PN junction, back to back. So you have N PN. Where's the N PN like this, right? So we have one diode over here, another diode over here. So let's draw the NP first. Okay, the NP first. Now, first let's draw at zero bias. It's easy if it's zero bias, where there's no the Fermi level is continuous. So first we draw the Fermi level. Then we know this is supposed to be N, P, and N. Okay. So now the N, they should be as close. The Fermi level should be as close as possible to the current action band. So we'll draw. And this is a homo. Let's assume this is a homo. What do you call it? Homo junction. So that's that. And then this the band gap. So this is the N. Then the next part is the P. Okay, the P. So we have to draw the P over here. And we know that the P, the P, the Fermi level here should be close to the valence band. So therefore we draw it like this. Maybe I should draw it. Let me reduce a bit over here, so I can draw. It's closer. So we draw. So this is the P side, like that. So roughly this homo junction. So it'll be like that. So again, the energy band diagram the same. Let's do it a bit here. And then finally, the other side here is the N, okay, which is similar to this one. Therefore, we'll just copy this over here to this side. And we copy, and then we paste. Okay, so yeah, something like that. Okay. Right, so the Fermi level is still continuous. Now, so what happens, we just join the line. So this is the BJT NPN at zero bias. Now, now we want to make it into a forward active mode. Okay, we want to change it to forward active mode. So how do we change it to the forward active mode? Number one, first we the NP here, the first base. So this is the emitter. This is the emitter, this is the base, this is the collector side. Okay. So now we want to forward bias this junction over here. So we know if we want to forward bias this junction, the Fermi level will not be continuous anymore. So this over here should rise. Okay. So how, if I can redraw it over here. Normally we draw it the other way around. So here we draw it. We can, if we make this if we make the P to remain constant, we can make the Fermi level to go over. Let's choose another color that maybe everybody can see. Let's say red, the Fermi level is the red color now. Okay, which means that the become like this, become like this, and then we just continue drawing like this. Okay, so if we know now the n is higher, then we know this is like, yeah, we are forward biasing. The red line here is the forward active mode. Okay, so we forward bias the base to emitter junction. Now we need to reverse bias we need to reverse the base to collector junction. Basically we need to reduce the n down over here. So what do we do? So let's say let's say reverse it a lot. So that's the collector, so it will be like that. Okay, so the red line over here, the red line that we see is the forward active. So you forward bias the base to emitter junction and reverse bias the base to collector junction. So what will happen now? Let's talk about the carriers. Again, similarly you can explain like the structure just now. So electron will diffuse from the emitter to the base. Hole also will diffuse from the base to the emitter. So some of the electron, when it enters the base, it will recombine with the hole over here, right? It will recombine with the hole, and most of it will just drift and to be collected at the collector side. So most of it will just drift towards that, and some of the electron will recombine with the hole at the base. So that's how in forward active mode how the BJT works.